All right. Hi, Nate.
Hey, Mike.
All right. So, what are we doing today?
We're going to look at Crawl4AI, which, as you can see here, is an open source LLM friendly web crawler and scraper. And it's a pretty powerful scraping library that I've been playing around with for the last month or so.
Hmm.
Um, so I thought we'd talk about what it's good for and what makes it different from other scrapers and crawlers that are available, and we can do kind of like a look at some examples of how you could use it, and I can even show an example of how I'm using it in one of the projects I'm working with.
Love it. Yeah, absolutely. So, let's jump right into it. So, what makes this different than other scrapers?
Yeah, well, it's built on top of Playwright, which is a popular web automation platform. Um, so that gives it the ability to scrape not just kind of normal HTML pages, but more advanced websites that have a lot of JavaScript. Because essentially it's like firing up a browser and emulating what a human would be doing in a browser. Um, so that just gives you a lot more flexibility in terms of being able to scrape sites that otherwise would be difficult to scrape with like a more traditional scraper.
Hmm.
The other thing that it has, which is the reason I picked it, is it has the ability to scrape using LLMs. So we talked about this the other day in our other podcast episode, but I'll just repeat it here. That what an LLM allows you to do is basically like look at the web page and figure out sort of semantically what the different elements are on the page that you want to scrape. So a traditional scraper, you'd have to explicitly define the different CSS selectors and XPath. And with an LLM-based scraping approach, you can basically just give it a natural language prompt. You can say like, I want you to scrape events, and I want you to, find the event title, the location, the date, the time, the cost, and then it will sort of intelligently figure out what on the page represent those elements, and then it'll return them. When it returns them, you can also tell it to return them in a structured format, like in JSON, so
Hmm.
that then it's easier to parse that data on your end and put it into a database or wherever.
Right. And what I remember you also telling me is it's very expensive in terms of tokens in to constantly be parsing using an LLM. And so I think you had mentioned that it generates a rough schema of what's expected. And then is there some kind of checksumming that it does to make sure the schema is still good, or how does it deal with when things change? So it pumps out the schema,
Mm-hmm.
meaning it thinks NBC News typically looks like this. If you want to grab like all the article headlines or something like that, you can use this quick XPath or what have you that it discovered earlier. Like how does it validate? Do you know? Have you run into situations where the schema fails?
Yeah, so it uses another open source library called Pydantic. Um, and what Pydantic does is it basically lets you define like a schema, and then it does some like basic validation. So if you are scraping using the LLM, you can define like a class and say like an event is a title, a description, location, date, time, cost, and you can give it like the types, right? This is a float, this is an integer, this is a string, and then when the LLM returns the data, it can check against that schema that you defined using Pydantic. So
Perfect. Okay.
I think I have an example of this. If I switch over to, let me see if I have an example here. I think this one, yeah. So here's an example of Pydantic. Um, you can
Hmm.
see up here we're importing from Pydantic, we're importing base model, and then we're defining an event model that is derived from this base model. And here we're
Right.
defining like the event title, description, date, start time, end time. All this stuff is defined in this class. And then when you actually do the scraping, you can then check the data that's coming back against these validators to make sure that it's coming back in the way that you expect it to come back.
Yeah, Pydantic is really kind of having its moment in the sun. It had always been a very popular language, but I think increasingly with LLMs and their uptake, you're starting to see you get a lot of fuzziness out of the LLMs, and so you need kind of the rigidity and the ability to define schemas that Pydantic provides. Yeah,
Yeah,
so very
exactly.
cool.
So you alluded to the what I'm calling like the hybrid approach, which is basically use the LLM for the hard part of defining the schema, and then you switch to a non LLM scraper. So if we go in the documentation, if we go to this LLM free, I
Mm.
want to highlight what really attracted me to the Crawl4AI library was this thing called, we're getting to it. It's in here somewhere. It's number 8. Here we go. Schema generation utility. So the idea here is that, given some HTML, just imagine that you got this HTML off a web page.
Sure.
This happens to be like HTML representing a product, a gaming laptop. Here's the price. Here's the specs. And so basically you say, okay, I want to define a schema based on the CSS, and then you use this JSON CSS extraction strategy. So it's going to generate a schema where it's going to feed in the HTML. That's
Yeah.
this snippet here. The schema type is CSS. You could also use XPath here if you wanted. You can see down here is an XPath example, and then you can define what LLM provider. So in this case, we're using OpenAI, but this could be any LLM that you want to use, even a local one.
Sure.
Passing your token, and then what's going to happen is you're going to get a schema defined, stored in this variable CSS schema that's going to describe how to extract this data from
Right.
this HTML, right? With the title, the price, the specs,
Yep.
and then you can define your strategy down here and say I want to use this JSON CSS extraction strategy using the schema that we just defined. So for repeated extractions, it's going to use this, and it's not going to have to call the LLM every time it scrapes the web. It only has to call the LLM the first time to get the schema defined, and then once it has the schema, then each subsequent scrape, it's going to use that. So,
Perfect.
So yeah, the benefit you can see down here. The benefits are it's a one-time cost. It's a smart pattern recognition. It analyzes the HTML structure, identifies common patterns. So I found that this is actually a really effective way to scrape lots of different sites, like where you may not know what the sites are in advance, right? So
Yeah.
The service product that I'm working on, SocialCal, I wanted to provide a way for anyone to put any website in a URL field and say, go grab all the events off this website. And I don't know what those websites are in advance because it's the users coming to the site that are specifying those sites. So I needed to have a way to generically, like a generic scraper that can scrape any website that has events on it and not have to, me manually go look at the site to try to figure out what represents an event. And that's where this LLM schema definition comes into play, is because it can kind of intelligently figure that out, like on the fly.
Yeah, no, that's a perfect segue. So I know you also have the SocialCal code up. Could we take a look at roughly how you're using it, and
Yeah.
maybe if you're feeling frisky, we could even try to run it.
Yeah. So this is the code for SocialCal. I have this directory here called scrapers, and you can see I've been experimenting with Firecrawl. I've been trying out a lot of different scraping libraries, trying to find one that works. And at this point, I've kind of settled on Crawl4AI, but I'm not like wed to that one. If a better one comes along, Olo Step was another one that I was testing for a while.
Yeah, can we just quick talk? Because one of the things I think anybody that's coming and looking at this, this is obviously it's kind of an introduction. It's always nice to know kind of the problem space. Could you talk a little bit about like Firecrawl or what was it, Olo Step? Just what their approach was and why you found that to be kind of deficient.
Well, Firecrawl was actually pretty promising. I ruled it out because of the cost. Like it was going to be somewhat expensive to use it. And when I found Crawl4AI, it was an open source library that basically has the same kind of functionality that Firecrawl has, but I can manage it all locally on my machine. I'm not dependent on a third party to do the scraping. At some point, I may decide I want to use Firecrawl because it's maybe more robust, or it handles bot detection better than. I mean that's one issue that I'm concerned with, is that whenever you're scraping websites, there's usually something on the other end. If it's a popular site, then it's often targeted. People are often grabbing data off websites. So sometimes these sites will have like bot detectors, and if they detect that you're scraping their site, they'll block you. They'll block your IP. So
Yeah.
so if you don't want to get blocked, then you need to use a service that can like rotate your IP address or go through a proxy. Which I haven't gotten into that, and I've seen some code in Crawl4AI that looks like it can use proxies, and it has some. I know you introduced me to Selenium Base, the undetected browser library that seems to do a pretty good job of going undetected, where it can crawl sites, and it sort of simulates human behavior, right, by scrolling and adding random intervals and doing things to kind of trick the bot detectors into thinking you're a human.
Yeah, it also uses the Chrome DevTools API additionally to kind of add and remove instrumentation at different times in the website's lifecycle. Because there's a cost to the bot detection, so they'll apply the bot detection at certain points, but not throughout. And it does a lot of things.
Yeah. So maybe we can jump in and I can walk through some of this code, explain.
Yeah. Would you mind showing SocialCal running? Is that something we could do?
Sure.
We could scrape a site, and then maybe we could set a breakpoint additionally and kind of see the APIs being called. That would be cool. All right. So it looks like you're using Django based off.
I am using Django. Yeah. So it's running here on localhost 8000. And I'm already logged in. So if I go to events, import events, you can see I've already got a bunch of different scrapers set up here. Is there a particular site, Mike, that you would want to scrape for events? And we can give it a shot here and see.
Let's do one that you already have predefined, because I don't want to be that guy that asks the hard question in the demo. And then we'll do one later and we'll see.
Okay. All right. Yeah. Well, let's go into this. I'm actually going to the Regatta Bar tonight to see Ron Carter play. I'm really excited about it. Awesome. So if we go to this scraper,
can I ask a question? Why does it keep saying CSS schema? To me, it's not a CSS schema. It's an HTML schema or a DOM schema. It's really bothering me.
Yeah. I mean, I think the reason they call it a CSS schema is because these are CSS elements.
Oh, sure.
Which are in the HTML, but these are actual CSS. Whereas if it was XPath, they would have an XPath expression here. I think that's why they call it that.
No, that's fair. That's a good point. Yep.
So this schema here was automatically generated when I first created this. When I first created this scraper, it executed that code that I was showing earlier to look at the HTML and then identify what are the different elements of the event? Like what's the title, the date, the start time, end time, location. And it just looks in the HTML to find those elements and then defines the schema. So I didn't have to generate this manually. This was all generated automatically. And if you asked the question earlier, well, what if the site changes, right? What if they do a design upgrade? Well, then you can just click this regenerate schema button and then it'll go and grab the new CSS selectors if they've changed. Right now, that's a manual thing. I have to click this button, but in the future, I could imagine there could be some testing, and if when it tries to grab the new events, it fails, then it could sort of self-correct and be like, oh, I'm not getting the events. Let me try regenerating the schema and see if that helps. So it could sort of self-heal in the event that there was a problem scraping the events.
Yeah. Yeah. Cool.
So what I can do on this page is I can click this test button, which is going to
Mm.
basically try this CSS schema and just, it's not actually importing them. It's just going to show me what, it's like a dry run. It's showing me what it would import if I chose to import it.
Oh, that looks great.
Yeah.
Yeah. Let's bring up the web page too, and if we could
Oh, yeah.
have the web page on one side and then the scrape results on the other. I mean, I think it looks great. It looks like, yeah, it looks like it got everything out of there.
Yeah.
Fantastic.
This is another reason I like the Arc browser, because I can use this split screen feature, and it just creates like two windows side by side, so then I can compare and see. Yep, it grabbed the. One thing that's a little bit annoying about this site is that there's one performer, Ron Carter, but he's playing both Friday and Saturday and Sunday, and
Sure.
each day there's two sets. There's a 7:30, and the way this calendar is set up is that they create like a new event for each showtime, which means that it kind of duplicates this show 5 times, right? Even though it's like the same performer, because there's different showtimes, it represents it as 5 different events, which kind of makes sense because you're going to pick one of those. You're not going to go to all 5. It just means that my event calendar has like 5 pictures of Ron Carter in it, as you'll see when we go there.
Yeah.
So once you've done the test, then you can click this import events button.
Okay.
And then what it does is it's actually extracting the events. And it's telling us that it only imported 2 of them because I'd run this scraper before.
Gotcha.
And it had already imported 18 events. So it's telling me that it updated 18 and it imported 2.
Mm-hmm.
So they must have added like some new shows to their calendar, which are the 2 new ones. So now we can then click view events, and then we can see these events that came in. And I'm having an issue right now where the venue is not getting captured, probably because there's no mention of the venue on this web page. So
Right.
I think I'm going to have to add some code that says like, if you can't find the venue, then default to, well, actually the venue is mentioned up at the top of the page. So it should have, the LLM should have noticed this and determined that that's the venue that we're talking about here. But because that is not associated with each event, it seems to be having a problem with that.
Yeah, so you don't, just to make it clear to the audience, so you don't specify like what your target goal from scraping is. You just say, here's a web page, give me every piece of data that you can get from it. That's what it does.
Well, not every piece of data. So if we go back to the code, I'll show you what we're actually telling it to get. So actually, let me go back to the
yeah,
one.
I saw your prompt back there.
Yeah, so let's look at, this is how I used to do it when I was using the LLM extraction strategy. These were the instructions that I was giving the LLM right here, which is like, for the crawled content, carefully extract all events without skipping any. You must process every single event, including the canceled events. For each event, you must find the title, the full description, the date, start and end times, venue details, all this. And then some special instructions like always return the dates in this format, return the time in that format, image URLs, blah, blah, blah. So this is how I used to do it, and it mostly worked. Because I had defined up here this schema, the event model, it was able to like validate that the data that's getting returned from this prompt matches that. Now, what I've done in this new version is, because we're not using the LLM to do the actual scraping, we're only using the LLM to define the CSS schema. The prompt is, you still need a prompt, right? You can see this is the new prompt here. You are an expert web scraper. I need to extract event information from this URL. And now this is just the first time when you're doing the CSS schema, right? When you're generating the CSS schema. We don't need to do this for the subsequent scrapes because once once we define the CSS schema, then we use the schema to do this extraction. We don't use the LLM anymore.
Right.
So create a CSS selector schema to extract the following fields for each event on the page. So we tell it what data we want it to find. And then there's some more instructions here. I had to add some special handling for websites that use a background image to represent the event image. And it was having a problem with that for a while until I gave it more clear instructions. There was also a website that was using data source attribute on image elements instead of source. So I had to add a handler for that. So there's a lot of like edge cases. And I would scrape a website and like some of the data wouldn't come through, and then I'd have to go troubleshoot and try to figure out, well, why are the images missing, right?
But if you can put that tedium into the prompts versus the traditional way, which is you were dealing with all the tedium, like that's a huge win in my opinion. So.
Yeah, and you can see here like there's like some special instructions for handling images and these data images. So this is the command that actually, or this is where you define the CSS schema, right? So it's basically saying generate the schema from the HTML content that you just pulled down using CSS selectors. And then instead of using the OpenAI, I'm using this Gemini for a number of reasons. Number one, it just has a much larger token size. So I kept running up against token limits, even though I pay for
the context window.
Yeah, like I think it was like a 200,000 tokens or something. And some of these web pages, when you factor in all the JavaScript and all the CSS and like everything on the page, sometimes I would exceed that. And Gemini just has like it's like 2 million tokens. It's like a huge.
What does it look like when you exceed that? Does it fail? Like, so would the OpenAI call fail, or does it just give very bad results because it's shifting the context window to accommodate it?
The scrape will fail. I could add some better error handling. Like for a while I was trying to like chunk. I would basically like not scrape the whole page. I'd just grab up into a certain number of tokens. But now you have an incomplete scrape, right? You've only scraped like half the events, and maybe you want to make sure you get all the events. So I found by just switching providers, that was a really simple solution. Just use this Gemini 2.0 Flash Lite model, and that worked a lot better. And it's also very cheap, right? Gemini doesn't cost very much. So this is.
Can I ask you a question? So it looked like the Regatta site on TicketWeb. That looked to be kind of a traditional HTML site where it's not one of these endless lists, endless scrolling type of things.
Yeah.
Is that true? Or?
Yeah. I mean, there is a next page here, right? If I wanted to scrape page 2, then I would have to tell the scraper, like, look for this element. Well, there's different ways of handling like pagination to. Because you're right, some sites have like infinite scroll where it just keeps loading the next batch of events as you scroll down the page. And Crawl4AI is capable of handling those kind of sites. It'll simulate the scrolling, and then as it scrolls, it detects that there's new events, and then it'll scrape those.
Do you limit it in some way, or will it scroll for forever potentially?
To be honest, I haven't added pagination yet. I'm still just like scraping the first page that I find because I figure
I'm very much playing devil's advocate here.
Yeah, I appreciate your questions.
Very impressive what you're doing here.
Yeah. So my thinking there is that events that are happening, way in the future, there's a chance that they're going to change between now and then, right? Like maybe the dates will get changed or the details about the event. And most people are looking for events like within the next week or two. They're not looking like months from now. I mean, maybe they are if it's a really popular concert and they have to get tickets for it. But I'm not too concerned right now with like getting every event, because some of these sites have events, like a year's worth of events, and that could take a long time to scrape all that stuff. Like the BSO or Symphony Hall books shows like sometimes 2 years in advance, right? For like Yo-Yo Ma's coming, we got to book him now. We want to make sure he's going to perform. So I'm not going to scrape like events that far in advance. I mean, I could just tell the scraper, like, just keep going till you get to the last page, right? But that could literally be like hundreds or thousands of events potentially, depending on, how many events the site has.
Yeah. Do you use a heuristic for token estimation, or do they have something that will tell you? Do they expose their tokenizer so you can know, hey, this is going to be 200,000 tokens?
I believe the Crawl4AI has some capabilities to tell you, like, make some token estimates.
Okay.
Yeah, I haven't really had a need for that yet, but
Yeah. The rule of thumb I've heard is that it's something like 3 tokens for, or no, 3 to 4 in some direction. Anyway, I can't remember, but certainly more tokens than words. So
yeah.
maybe 4 tokens for every 3 words. Yeah.
Yeah. So once you've got the CSS schema, then there's this function to actually run the schema, and this is what's actually doing the scraping. So you define a web crawler, and then there's a bunch of handling here for the images, like I mentioned before, and then we define the extraction strategy, and we say we want to use the JSON CSS extraction using the CSS schema that we defined up above, or that we generated. And then we config the crawler, telling it to use that extraction strategy. And then down here, there's a lot of like auto-generated code here that's not really necessary, but Cursor wanted to do some validating of things. Like if the crawl failed, it wanted to like inspect the HTML. And
yeah, I see beautiful soup.
Yeah, I don't really like that beautiful soup is in here because it creates another dependency, and I'm not really using beautiful soup, but you can see it's the else if no content is extracted. Then it does some like forensics to try to look at the raw HTML and try to figure out why it didn't scrape properly, which I appreciate, right? This helped in debugging, but it's kind of unnecessary code. It doesn't actually help the user at all. Although this could be useful to show the user, what data it's finding and how it's trying to extract it. If you were debugging that CSS schema, for example, like this could be helpful to kind of like see this debugging output.
Sure.
Yeah, and then it extracts the content and formats the event. This is iterating over all the events that it finds on the page, and it's grabbing all the data. There's some handling, some date time parsing magic that we have here. You can see we created a special utility, this time parser, and this function in particular is quite involved. This extract date time from string. If you want, I can give you a quick look into that, because it's quite. When you think of all the different edge cases. Yeah, I discovered after generating all this code with Cursor, I discovered there's a Python library called date parser that, given any date time string, it intelligently figures out it can return like a date time value. So I'll probably switch to that, and just like it'll cut this code like down to like 1/10 the size probably. But you can see there's like all these different all these different scenarios of like how people represent events.
Yes.
And it's kind of shocking how many different ways people represent a date time on their event listings.
Yeah.
When you try to handle all the different cases, it's kind of mind-boggling.
Have you ever played regex golf or any of these regex puzzles?
No, but I can imagine.
You might enjoy it. It's kind of fun. I think
you can see like look at some of these regexes here. Like these are just so this is not pretty code, right? It's very messy, and it's basically trying to handle every possible combination date time string, and I'm sure I haven't captured all of them, right? Every time I scrape a new website, there's some new representation, and I'm also really curious to see if I can use an LLM to do like a second pass, like once it's used the CSS schema to get the date time string, then use an LLM to then extract the relevant bits from that from that string, rather than writing all this Python code to do it, because this is, as you can see, quite involved, and I suspect the LLM would potentially save a lot of time. But again, that gets back to the cost thing, right? If every date time string you have to call an LLM, it can slow things down and get expensive. So I'm
Yeah,
gonna,
but if you've cleaned it up enough, it might be something where you can throw a very small model that you're locally hosting or something like that. Maybe a 1.5B model is enough.
mm-hmm. That's true. It could use a smaller model. There might even be some models that are specifically tuned for parsing date time strings.
Yeah,
They've fed
I
every
mean,
possible date time configurator. The one that I'm looking at, let me see if I have it in my I don't have it in my history. Um oh yeah, here it is, date parser. So this is the one that was recommended to me by someone on the Boston Python Slack channel. Um it even handles other languages, which is pretty cool. So like here's, in Spanish, and this one's in French. And so the nice thing about using a library like this is if I put this in SocialCal, now SocialCal can go scrape events off of non English speaking
yeah,
websites, and it'll magically handle the dates. I don't have to write a bunch of Python code to do that.
yeah, no, very cool.
Well,
All right, well, so, oh,
we're
I
at
think
we're at half past, so maybe we should
yeah,
wrap it up. What do you
that's
say?
what I was thinking too. I was thinking if you had any plugs you wanted to do. I know SocialCal is semi-public. I'm not quite sure how public. Is this something people can
Yeah,
access? Right?
it's live. You can go to socialcal.io and create an account. It's rapidly changing from week to week, so adding new features and fixing bugs, and it's kind of a work in progress. So there's going to be still some kind of funky things going on the site, but it's for the most part functional. Has the basic functionality of scraping websites, and I didn't show the feature to add an event to your calendar, but that's another
Hmm.
nice feature. To basically, like, I want to add all the events that I've scraped now to my Google Calendar, so I can see when they're happening and compare them to my personal calendar and see what I can go to. So if you grab this iCal feed, you can import that in your Google Calendar, and that was one of the features that I really wanted to have, so that I don't actually have to go to socialcal.io to see all the events. They just come right into my tool I'm already using for calendaring.
Yeah, yeah, yeah. Just quick question,
Mm-hmm.
little tangent here. So, is this all templates that are being rendered, including this calendar, or what are you using? Do you have a React front end as well, or is this purely Django
No,
rendering?
this is all Django. I for a while I was experimenting with the React front end, but I'm not super familiar with React. So I just decided for the site that I'm building, I don't need anything super fancy, and so these are
Calendar looks great.
yeah, these are
Yeah,
just Django templates. In the future, I may switch to React, to create a more responsive, like mobile friendly version of the site. But for now, this is getting the job done.
yeah. All right. Well, perfect. Thank you for the introduction to Crawl4AI, Nate. Appreciate it. And this has been AI Tool Time.